This is for you. Did you read it? Okay, just make sure you did. And of course, we all know what a buckeye is, right? A worthless nut. I can say that because I was born in Cincinnati and I grew up in Fairborn, but I haven't lived here for over half a century. So anyway, enough of that. Before I get started too, I would like to tell you about the Research Assistance Database. How many people know about it or use it? I use it quite frequently. It's many times I want to find out what's been written in the creation literature on some subject that I'm looking into. And this is the best way to do it. It's got thousands of articles and books and other resources. They're abstracted. You can search by title. You can search by author. And since it's abstracted, you can search by topic or keyword. So it's a very useful sort of thing. Again, I use it quite frequently. I highly recommend it for that. Well, on with my presentation, which is about the current state of astronomy, the creation model. I want to survey briefly where we are and also where we are going. So there were 3 earlier reviews done. The first one was done 50 years ago by George Mohlfinger, and I happened to take a few classes from him. I knew him pretty personally as well, a fine gentleman. And he did the first review way back then in the CRSQ, the Creation Research Society Quarterly. And that sort of inspired me to 25 years later to do my own review at one of the ICCs. And I let 20 years go by and I did another review just 5 years ago. It's not time to do another full review of where we are, but I do welcome this chance, this opportunity to do kind of a short review here. And I want to review quickly the early work that was done. This goes back to the 1960s. And there were really 3 major themes that you saw coming up again and again. One was criticisms of evolutionary ideas. Sometimes I call this Big Bang bashing. And that plays a role at some point, but we need to move beyond that eventually. And then there's also, there were a lot of discussion of recent age indicators in astronomy, some of which were good, some of which were not so good. And we continue to see a few more of those come along from time to time. And then there was some attempts at identification of design in astronomy. That's something that I've wrestled with for a long time, and I've really written only a little bit about that myself. And I think we need to turn our attention to that some more and be more serious about it. But really in the first 30, 40 years, it was not much model building. It was really piecemeal at best, and we just really were kind of stymied for progress. And there are 3 broad areas that I think need attention. I've been calling attention to this for years and years, but it doesn't hurt to keep repeating this. One is near environment to the Earth, including the Earth, the solar system. Why do we have other planets? Why do we have 2 basic types of planets? Why do they have many natural satellites? Why do some of them have ring systems? Why are there asteroids? Why are there comets? Those kind of questions. And we've had a few guesses over the years, a lot of them not very good, I'm afraid. But we need to really delve into this some more. But that's one of the things we need to talk about, it's dealing with solar system. Why are there craters in the solar system? Where do they come from? How do they fit into a creation model and maybe a catastrophe model? So all sorts of questions dealing with solar system objects. And then the next step up would be stellar astronomy. And that's sort of my passion because I've been working with stars most of my career. So I'm a stellar astronomer, you see. And so, okay, I'm glad you caught that. And so it also would kind of morph into galactic astronomy, the structure of our own Milky Way, but also other galaxies. And that kind of slowly morphs into the third topic of cosmology. So you need to be careful where you would delineate that. But I think of the 3 broad topics here, stellar astronomy has been shortchanged the most. And I get frustrated sometimes when I read the creation account because when you're reading the day 4 account, it talks about the luminaries God made, and a lot of attention seems to be focused on the sun and the moon, which are called the greater and lesser lights. And then it's almost like an afterthought, it just says the stars also. And it's almost like the Lord said, I'm going to put that in there just as an afterthought to frustrate Danny, down in the future on this. But it's almost like he just, I got to mention these too, like they're not that important. But to me, they're real. I just think stars are incredibly cool objects. And so those are the 3 broad areas. We've had mixed results so far in progressing in this, and I think there's several impediments to the progress that we have. One is the lack of qualified researchers. I used to count on my one hand how many creation astronomers there really were. PhDs, all right? Masters, we have some master's people, they're good too, but PhDs is really what I'd like to see as much as possible. I'm glad to report I'm on my second hand. But I'm a wee bit greedy. I want to take my shoes off. You're not surprised to hear that, are you? And count on my toes as well. And I'm very pleased to know that we have some people in the pipeline. I know at least 2 people here at this meeting who are graduate students in astronomy and astrophysics applications. And there may be others I don't know about. And if you are, come let me know about you. I want to hear about you, okay? So we can kind of get together and work on some things. But I'm really excited at the fact that we have more and more people coming down the pike, and we have again very many qualified researchers, those with PhDs and those with masters as well. But another impediment has been lack of biblical specifics. And again, it gets back to the day 4 account. There's really very little. It tells us that God said, "Let there be lights in the sky," and gives them several purposes. He made a greater light to rule the day, the lesser light to rule the night. He made the stars also, and he gave several purposes, and then we're done. And I'm sitting there just thirsting for more information to come out of this. And so we have this creation of the astronomical realm, as it were, on day 4. And that's the primary bit of information we have, just the creation of these things without any specifics given. Now, there's a little more there. One possibility is that this creation of this expanse, this rakia, as Russ Humphreys talked about last night, that many more of us are now increasingly believing that is the creation of this rest of the space of the universe. And I'll say more about that in a couple of minutes. And I like to contrast this with the biologists and geologists here. Now, they may be frustrated in trying to develop their models, but I think they've got a very clear path. With a geologist, you've got a wealth of information, several chapters dealing with a flood and its aftermath. And we get like 4 verses, in the first chapter. And then the biologist, you've spent a lot of time talking about created kinds. What are they? And identification. There have been scads of papers written on that. And of course, a related thing. So I think we're always envious in astronomy. We're always envious of our biology and geology brethren and sisters because they seem to have a lot more information to work on. And that frustrated me for many, many years. And then one day I suddenly realized, oh, wait a minute, that gives us a lot of freedom now, doesn't it? We are really free to pursue some really wild ideas, and believe me, a lot of them are very wild. And as long as it's consistent with Scripture, we're free to pursue that. And in astronomy, we astronomers, pardon the pun, but we do deal with a lot of far-out ideas already. So it's really natural that we can really think outside the box. However, with this great freedom, there's also great danger. And that's the fact that we can maybe lose sight of the Scriptures. We should always come back to the Scriptures. That should be our touchstone to compare things to and make sure they're in line with Scripture. Anything that's not ruled out in Scripture is okay to do, but sometimes we cross the line and forget there's a few things that are excluded by Scripture. And just because our ideas are not contrary to Scripture necessarily, it doesn't mean they're right either, does it? So we need to be very careful. We can become kind of arrogant after a while and think these ideas are right when maybe they really aren't. So we've got great opportunity, great freedom. We also have great danger. And I think with that, then you put those two together and you have great responsibility. And we all need to be humble about this. And the most important thing is to, be humble about our ideas we have. I've staked out a lot of positions out there, and I think sometimes people treat me with more deference than I deserve in all of this. But really, folks, I'm human. I make mistakes, and I don't mind being corrected from time to time. So we all need to have checkups from one another and get checks from one another to make sure we're doing this more properly. All right, solar system progress. We've had really a remarkable advancement in the last couple of decades with cratering. Again, some that was mentioned last night in some of the surveys that were done. And cratering, I think it's pretty clear most of the craters in the solar system and on the moon came from impacts. But when did those impacts take place? And at one time, most people were trying to say, well, the impacts occurred at the fall. And I get a little concerned when people try to put too many catastrophes onto the fall. It was a pretty bad thing, but sometimes we just start multiplying them and multiplying them and multiplying. We need to maybe be a little conservative on our catastrophes. And some people want to dump them on the flood. You know, some people say, well, they're all at the flood instead of all at the fall. And I made a modest proposal almost 25 years ago now, where I suggested that maybe some of the craters came from day 4. You might say, oh, that's terrible. I won't go into details on that, but really, do craters on objects outside the Earth really represent a problem with the very good of creation? I don't think so, but I'm not going to talk about that right now. You can look at what I've written on that, and we've actually debated in some of the literature as well. And what I've come to understand is I like a hybrid. I like some of the craters on day 4, part of the creation process of the astronomical bodies, and also at the time of the flood. I'm not too keen on the fall, but there are people out there on the fall. We've had some good discussion over the last 10, 15 years on this in the creationary literature, where I think we've done it in a very gentlemanly manner. We've treated each other very nicely, and in some respects, maybe I think we're better examples than some of the geologists and some of the biologists can be. I've watched your fights, and they've gotten pretty vicious. And I must say, within the astronomy circles, we've been very kind to one another. I don't know why we're different, but we are in that respect. So pay attention to us and emulate us, okay? And then there's Mars and Venus, very fascinating things. You know, back in the 1990s, people started talking about there being a global or near global flood on Mars. How many people are aware of that? A global or nearly. By the way, those weren't creationists who were saying that. These were secular scientists saying there was a global or near global flood. I remember that first came out in the 90s, one of the rovers they put on Mars. There was this great cartoon in the Charlotte Observer newspaper. It had this NASA people talking and saying that the rover found evidence that there was once a big flood on Mars, and the rover's sitting there and the camera's pointing at this big arc sitting there on the thing. And I took it out to me with ICR. I was out there that summer, and John Morris loved it so much he asked if he could have it, and I gave it to him. They didn't even get a copy. So if anyone has a copy of that, I'd love to get that Doug Marlette cartoon about that. But there was really a global or near global flood on Mars, and you know what's strange about that? It's a planet where there's no water. That's amazing, and yet you've got, like, if you smoothed out the Earth, you have like 1.5 miles or so, 2 miles of water on the Earth. It couldn't be a flood on this planet. And then look at Venus. They had an overturning. Again, the secular scientists started saying this in the 90s. They were saying that there was a rapid overturn in the recent past on Venus, completely overturning the surface of Venus with not really plate motion, but some real tectonic activity going on. And how recently? Well, like 150 million years ago on their time scale. It's recent, and it's like this and a short duration is 1 million years. We can compact that really nicely on our time scale, can't we? So it's almost as if the Lord made a planet that's closest to us have this incredible tectonic upheaval in a very short period of time that now secular scientists recognize. And the next planet out from us, he put a flood on it where there's no water today, as if to suggest that maybe both of those might have happened on the Earth. But no, people couldn't have happened here. So I think that's some real progress in starting identifying some of the purposes of the planets out there, and I'm keenly aware of that, and I'm trying to figure out why are these things out here and what lessons they have to tell to us. And then the exoplanets, that's exciting. Until about less than 30 years ago, there were no exoplanets, and I already put up there, I checked on this, just 5 days ago, the total was 5,470 exoplanets. That's a lot of exoplanets. And 30 years ago, if you would have asked the average scientist or an astronomer, you would ask them, when they have found over 5,000 exoplanets, how many of those will be Earth-like? I think most of them would have said, oh, hundreds of them. Well, how many have they found that are like the Earth? 0, zilch, none. There are occasionally reports of this Earth-like planet found around a star. And it usually takes me about 10 minutes looking on the internet to give you 3 reasons why it ain't true. Okay, I won't go into that now, but trust me, the information coming in is the uniqueness of the Earth. And I think back, when this started happening 30 years ago, a lot of creationists were really again, and I was very suspicious myself, I must admit. That was a turning point for me at one point around 2000 or so. But a lot of them were suspicious, and I had to ask them, well, what are you worried about? They're going to find an Earth-like planet? Well, they haven't. And I do believe the Earth is unique because I believe in special creation. And secular science is proving that to be the case. We need to capitalize that, folks, and use that. It's also showing the uniqueness of the solar system. Before all these exoplanets, they'd worked out this beautiful theory about how the planets formed. It was geared for here in the solar system, and it worked beautifully why there are terrestrial planets, small rocky planets close to the sun, and then more gas giant, the big ones, pretty far out from the sun. So what did they start finding? They found a lot of gas giants really close to these other stars, which made no sense. And it's suggesting now that the solar system is an odd one out. It's very rare, apparently. Isn't that cool to be a time we're alive to find all this sort of stuff? And what about the stellar astronomy? Well, as I said, there's been little progress on that. And one of the impediments, I think, is trying to separate out the stellar structure from the stellar evolution. You know, the concept we have of the sun's energy has been for better part of a century is that the sun gets its energy from nuclear fusion in its core, turning hydrogen into helium. And we now have direct evidence of that from neutrino fluxes, going back to over 20 years actually, that confirms that is indeed the source of the sun's energy. For a long time, there was a solar neutrino problem you may have read about in the creation literature. It died over 20 years ago because they discovered that all the neutrino fluxes from the sun were like 1/3 of what they're supposed to be. And then they found out, despite what the particle physicists told us, that neutrinos, there are 3 types and they oscillate between the 3 types. And the sun only produces 1 type. And by the time they got here from the sun, they had oscillated away. So now there's equally split between the 3 types. Beautifully matching and giving us great confirmation that the sun gets its energy by that source. And so there's strong evidence, I believe, from other lines of evidence that the sun's structure is well understood. Not perfectly, but we've got a good understanding, comparable to what we have on the interior of the Earth now, I think. And we also have some evidence for structure on the other stars. But here's the rub. What happens if you convert hydrogen to helium? Well, you change the mean molecular weight inside of let's generalize it to stars in general. You change the mean molecular weight of the core, and that change in mean molecular weight reduces the number of particles, which means that if you follow the ideal gas law, you've decreased the number of moles, and the thing starts to contract. The volume gets less, the temperature goes up, and the fusion rates inside of stars is critically dependent upon that temperature. So as the temperature increases in the core, guess what? You produce more energy, which drives the flux out through the star, and the star becomes brighter. Very slowly, but it becomes brighter. And what I've just described to you is that this star is just evolved. Yeah. So how do we separate this very good stellar structure from the stellar evolution? I'm afraid I don't have a great answer for you on that one. I'm still wrestling with that one myself. One thing I can say is that, remember I said it happens very gradually. If the cosmos is only a few thousand years old, no real big change. But I really hate to just say it's a matter of time. I'd like it to be a little better than that. Furthermore, if we were to scrap all of stellar evolution theory today, what could we replace it with? There's a tremendous amount of detail in that stellar evolutionary theory, more than I could ever go into in a presentation like this. So what do we replace it with? We really need to have a positive thing coming forward, and that's what's really stymied me, because that's what I'm really interested in, and I don't have a clue how to do that by myself. As for cosmology, the most interest in the last 10 years or so has been focused on that, it seems like. I think sometimes, actually going back more than 10 years, but I think in many respects the motivation people have is to try to solve the distant starlight problem. We now have like a half a dozen solutions, folks. I think we have enough of those for the time being. Let's just kind of mull those over and cull that herd a little bit and maybe concentrate a little more on some other things without the motivation being trying to solve the starlight problem. And a big question that we've wrestled with going way back is, when did God create the space of the universe? Was it in Genesis 1:1? Well, I certainly believe that for myself for a long time. If you read my first book I published out there, that's what I say on the first page, I think, of that book. And I badly need to revise that book because I don't believe that anymore. And we learned this from the first generation of creation scientists going back 60 years ago now, where they posited that in the beginning God created the heavens and earth. The heavens there refers to the space of the universe. Why did they do that? Well, because of the description of day 2, where it talks about this rakia, or expanse, or firmament in older translations of English translations, which, by the way, is a bad translation, I'm convinced. And they thought that was the Earth's atmosphere, and it supported the canopy model. And that's what I grew up knowing. And then lo and behold, we began to move away from that. And I dare say most people in this room are probably not in favor of the canopy model, though it hasn't gotten to the pews many times. Is Russ here tonight? He tells a story about the woman. He says, you're taking our canopy away. Remember that story? And I've encountered that myself. There are certain places where the canopy is really big, but most of us have left that behind. But you know what? Even though we left that behind decades ago, we didn't really go back and reinvestigate, well, what does day 2 refer to? We just kind of skipped over that. And finally, about 10 years ago, I'm looking into it, and I'm thinking, whoa, I think it's talking about the creation of the space of the universe on day 2, which is then where God placed those luminaries on day 4. And little did I know it, other people were coming to that realization as well. And I think that's becoming more and more dominant. I think that's the correct way to go. There are people who are going to disagree with me, I know, but that's fine. You have a right to be wrong. And we can, I think we're going to make real progress now, because I think that's a big turning point for me. I think we now have a foundation to work on a modern cosmology with that. And then a question related to that is, okay, the whole purpose of this rakia on day 2 is to separate waters below from waters above. And the waters below, it's pretty obvious, but what are these waters above? And we still have disagreements on that. And I've written on this myself, and other people agree with me. Some people disagree with me, and we need to thrash through that. But that's an important key there. And some other things. The Hubble relation. The Hubble relation, is that really a real thing? Well, yes, it is. The Hubble relation, all that is a plot or a relationship between measured redshifts and measured distances of galaxies. That's it. That's all that it is. Now, does that mean the universe is expanding? I think that's what confuses people here. The data are simply the relationship between redshift and distance. Now, the interpretation is that the universe is expanding. And I happen to believe that's the simplest, most straightforward interpretation, and it's the one that I favor. However, I am well aware that it could have some other mechanism, and I'm very open to that possibility. I'm not really, in fact, I'm less enamored with the interpretation of expansion today than I used to be, but I'm still bullish on that. But I could be talked out of it relatively easy if you have some good idea to sell me on here. But for the time being, I'll stick with that. That's something we need to discuss, but don't diss the Hubble relation. I think it's observationally valid. It's really got a tremendous amount of data behind it. And then there's this cosmic microwave background that was given as one of the great evidences for the Big Bang. It's this radiation field, fairly uniform in temperature, coming from every direction in space. What is it? Well, how does it fit into a creationary model? A good creationary model, at some point, some cosmology based on Scripture ought to be able to give us a plausible explanation for what the CMB is. And then there's this dark matter business. In a shameless act of self-promotion, I'll be speaking about that Wednesday morning, all right? So please come. I'm no secret, I'm very bullish on dark matter. There's a very strong case to be made for dark matter. And I think that's something we need to thrash through. I think this point is maybe one of the biggest issues we have to deal with in cosmology, and we've got people running in all sorts of directions. I hope I can change some minds on Wednesday morning. Related to that is dark energy. I'm less bullish on that, but the thing is, and I'll explain this on Wednesday if you come, I promise, it is based upon observations that are interpreted in terms of the Big Bang model. No Big Bang, no dark energy, but hey, there still is the data related to that. How do we explain that in a cosmology? And that is a big question for us. We need to explain that. And then there's the question about general relativity. From time to time, a very long time, a lot of creationists are very suspicious of special and general relativity, and I totally disagree with that. Maybe I'll give a talk on that at some point. I'm very bullish on that the more and more I learn about it. And I do believe general relativity and special relativity are our friends. They really are good for us to have. And I see less and less in that. I think now people are more up to speed accepting it, but I think there's still some resistance out there. Well, I thank you very much. I yield the remainder of my time.